So first, the denominator for all of our probabilities is we need to know the number of ways to choose 3 doors out of 7, right? So if you have 7 doors to choose from and you want to choose 3 of them, do 7 choose 3, you're a pro at that, you're going to get 35. And that's going to be the denominator for all of our probabilities because that's the total number of possible ways to choose 3 out of 7 doors. Now, for the first guy, if we want to drive home with 3 cars, this is going to be our setup for all of them this way. We have 3 doors with cars, and we want to choose 3 of them. We have 4 doors without cars, and we want to choose 0 of them, because, again, we're picking 3 cars total. So the 3 plus 0 should add up to 3. So 3 doors with cars, we're going to choose all 3. 4 doors without cars, we're just going to choose 0. So if you do these out, that's 1 times 1 is 1. So there's one way to choose all 3 doors with cars. And remember, so one way to do it out of, remember, the 35 ways possible. So 1 out of 35 for that. Second guy, same feel. We want 2 cars. So we want 2 with a car and 1 without a car. So there are 3 doors with a car. We want to choose 2 of those. And 4 doors without a car, we're just going to choose 1 of those. Choosing 3 total. The 2 plus the 1 add to 3. Just like the 3 plus the 0 added up to 3 up there. Crank these out because you're pro at that. This will give you 3, this will give you 4. Multiply those, total of 12 ways to get 2 cars. To make that a probability, 12 ways that we want out of 35 ways possible. So 12 out of 35. For part C, the probability of getting at least 1 car. At least 1 car means 1, 2, or 3 cars. So we've already found the possibility of getting 3 cars or 2 cars. We just haven't found the probability of getting 1 car. So let's do that now. If we want to choose exactly 1 car, there are 3 doors with cars. We want to choose 1 of them. There are 4 doors without cars. We'll choose 2 of them because we're choosing 3 doors total. Crank that out, 18. So at least 1 car, we could have 1 car, 2 cars, or 1 car, 2 cars. I can point. This is 1 car, this was 2 cars, this was 3 cars. So 18 ways to do that, 12 ways to do that, 1 way to do that. So 18 plus 12 plus 1 combination that we want out of the 35 ways total. So 31 out of 35. For part D, the probability of walking, i.e. getting no cars. So we want the probability of not getting any cars. So there are 3 doors with cars. We want to choose none of them. There are 4 doors without cars. We're going to choose all 3 of those. Again, those add up to 3 because we're choosing 3 doors total. So if we crank that, 1 times 4 is 4. So why did I write 1 here? I should have written 4. So there's 4 ways that we want out of 35 ways total. So now when we come down to do this expectation problem, we have all the probabilities here. Our possibilities, we could have 0 cars, 1 car, 2 cars, or 3 cars. All the probabilities are here. The way to choose 0 was 4 out of 35. Choosing 1 was 31 out of 35. Choosing 2 was 12 out of 35. Choosing 3 was 1 out of 35. We've done all the work for the probabilities already. What the money that we would get if we didn't choose any cars, that's like getting no money. 1 car is worth $36,000. 2 cars is 2 times 36,000 is 72,000. 3 cars is 3 times 36,000, which gave me 108,000. So to find the expectation, it's just this times this, plus this times this, plus this times this, plus this times this. So we did that. and I cranked them all out, just multiplied the tops together. So the 31 times that gave me that, 12 times that gave me that. I left the bottoms all the same because they were all 35s, and that allowed me to add all the numerators up. And I divided by 35 to get a final answer of that.